Yeah, it makes sense. Yeah.
Awesome, awesome. So please interrupt me anytime if you have any questions. So let's continue. So this is our schedule. As you see, the schedule is also in our Google Classroom, right? This is just the calendar for the month of March. Today is the 4th. So we're having our class at 2 p.m. We're always going to have class at 2 p.m. and this is Eastern time. All right. So 2 p.m. our time, convert it to your time as well. On Saturday and Sunday, we'll have class from 2 to 4. And then on Monday, it's going to be in the evening, 6 o'clock to 8 o'clock. Okay. So 3 weeks, or sorry, 4 weeks, 3 days a week, Saturday, Sunday, and Monday. This week, we're going to cover a bunch of the first area. Next week, we're going to start up and finish the second domain. And then the third week, we'll complete the last domain before we start doing a lot of practice. But at the end of the day, we're going to be able to be ready for Microsoft certification so that we're going to be certified with the Azure fundamentals. So without much ado, let me start right away. What is cloud computing? Just an introduction. Okay. Today we're going to talk about the introduction of cloud computing, covering things like cloud concepts, like the core concepts of cloud, which is true for Microsoft, Amazon, Google, any cloud platform out there. And then we'll also talk about deployment models for Azure and understanding what shared responsibility principle is. We'll also talk about some of the services, all the services that are deployed on the cloud. That said, a few things that we need to achieve today. It looks like a lot, but at the end of this class, everybody should be able to define what cloud computing is and describe the shared responsibility model. We'll also describe infrastructure as a service, platform as a service, and software as a service. We'll also talk about some use cases. When do you get to use each one of these? When is it important? Okay, because when you have a certification, the questions that you'll be asked, they're going to paint a picture for you. For instance, they'll say, hey, you're working for company ABC. They want to move their deployment to the cloud. What do you think they should do? They want to do this, they want to do that, they want to accomplish this. What kind of service will work for them? So that's why we want to talk about those use cases. Okay. After that, we'll probably take a short break, maybe 5-10 minutes, so that everybody can recoup. And then we'll talk about cloud models, whether it's public, private, hybrid, or maybe multi. Okay. And also talk about when we should use it, when we should not use it, when you can recommend it, and when you should not recommend it. And then finally, we'll talk about the consumption-based model, how the cloud is priced. Okay, the pricing models for the cloud. At the end of the day, we should be comfortable understanding those basic things about cloud. All of this is what makes up part of the cloud concepts that are usually tested for your certification. All right. What questions do you have? Any questions? No questions so far. Mr. Egbe, any questions?
No, not so far. I'm good.
Okay. So what is the reason we're doing this? We're doing this course to be able to prepare for Microsoft certification. There are many reasons why you should get certified for Microsoft, okay? And there are many reasons why you should start with this course. There are many different types of fundamental courses. There's data fundamentals, there's AI fundamentals for artificial intelligence, but we're just going to do Azure fundamentals because that's going to show or demonstrate that you have basic computing knowledge and also that you have gone through a curated guide and gives interest or shows your interest in the cloud. Those are the main things that people look at before they give you employment. So I'll also give you some resources to see all the other certifications out there, but you always want to start with this. For the exam, it's like a 60-minute exam. It's not very pricey. It's $99 or 100 US dollars. Most certifications are more expensive, but with 100 US dollars, getting certified putting that on your resume, putting that in your social media, whether it's LinkedIn and so on, it makes the recruiters get confident that this guy knows, he has proven that he knows this field. But the things that you need to know before you take this exam are broken down to these three main areas. Okay. The three main areas, they just need you to describe things. You don't really need to do them. You don't need to prove them. You just need to describe. If you can describe what the cloud concepts are, if you can describe the architecture of Azure and the services, if you can also describe how it's managed and governed, then you're good. So what are the cloud concepts? Those are some of the things I told you we'll learn today. Okay, how it's built, how things were done traditionally, how it's done in the cloud. What is cloud architecture? To understand the different ways in which it's broken down. Just like think about your house. If you have a house, the house is broken down into certain areas. There are different types of houses. There are different ways in which you can go ahead to build it. The services that it provides, there are three main services that are provided on the cloud: the computer or the compute power, the networking power, and then your storage. So those are the three main things. Upon everything that you see on there, they fall under those three categories. We'll talk about those next week. Finally, we'll talk about managing. How do you access it? How do you manage it? How do you create these things? How do you update them? How do you delete them? We'll talk about those, and then governance. But at the end of the day, you should be very good. At the end of this month, if February goes by without you taking the exam, I'll personally be angry with you. In April goes by without you taking the exam, I'll be angry with you. So if we go back to our calendar, you'll see that today is the 4th of March. We're starting with the first class. When we go through all these classes, by the time it's Easter on the 9th of April, you should have at least registered for this exam for $100, and you should be good, so that you start getting ready for the next level for us to get into more in-depth stuff. All right, sounds good. So it's not going to be technical. I'm going to give you a big picture overview, but if you want me to get technical in order for you to understand it, I'll break it down to you in layman terms, and we should be able to understand very easily. Okay, sounds good. Perfect. So what is cloud computing? Can anybody tell me in their own words what they think cloud computing is? If you're talking, you're on mute, and there's no wrong answer. We don't have a volunteer yet. Mr. Ella, you're still on mute.
Yes, sir.
What do you think cloud computing is in your own words?
I think cloud computing is just a means of storing data in space, like somewhere.
Exactly correct. Exactly correct. I like that idea. Now let's look at it this way, right? There's a few of us here on this call. If we decide that you want to create, you want to start your company, right? Imagine you're working for a big company. Maybe you want to start a military company, or you want to start industry in food, or you want to start a transport company. Whichever company you want to start, let's say you're going to have a bunch of computers and so on and so forth. And also you need those computers to be connected. You need all these people. I mean, think of your little office, your small office or a big office. You have to be able to buy computers to set things up, get them connected to one another so that everybody can get connected, and so on and so forth. Rather than having to do these things that traditional way that is always done. If we want to start a new university, we buy computers and put it at that university, buy cables, connect all those computers and so on, create a network and so on and so forth. Someone else is doing this for us. That's what is known as cloud computing. So cloud computing is delivering all these computer services over the internet. Okay. So Microsoft, Amazon, Google, and a bunch of other companies out there, they have taken their time, their money, and build data centers, build big warehouses where they have all these servers that we can store our stuff in there. Those data centers are connected to one another with fiber optic cable all around the world. Okay. So when you want to, rather than you having to rent a place in Douala or rent a place in Limbe and have a server in there and then start figuring out how you're connecting that server to the internet and so on to get all that done for you, instead of doing it manually, you rent the server that someone else already created. So that's pretty much what cloud computing is. For example, if you use Microsoft Word on your phone or on your computer, you don't get to install that on your machine. You're just using it over the internet. For example, if you're watching Netflix, you don't get to download anything. You're just watching the movie over the internet. Someone else has that movie saved somewhere in a storage, and it's being used by you. So does that make any sense? Does that help?
Well, it's not really clear. Still not clear that way. You can.
Okay, so still not clear because I have to still break it down based on the services. So normally, let me go ahead and paint a picture here. Normally, if you want to build a company, right, you're going to first start by having a bunch of computers, right? You
Yes.
get one computer. Oops, I can't get my. Okay, there you go. You get one computer, two computers, three computers, and so on. I think I have this disappearing. Let me change it to not disappear. Okay. So you have all these computers that are connected to each other. Instead of saving your money to have these computers, because the computers have to also be connected to one another, and you have a person using this or using that and so on. And then putting money to buy computers, hardware and software and so on, getting somebody to be able to maintain it and manage it each time. Rather than doing that, you just go ahead and pay for someone that has already done it, and they give you access and you're able to do all those things. Does that make sense?
Yeah, makes sense.
But you, depending on what service you want, do you want them to just store your pictures? And then fine, if you want them to just store your pictures, you can use Google Photos. It stores your pictures. If you want it to store your movies or you want it to store your documents, you can use Google Drive. You can store your documents rather than you storing it on your personal computer or one of these. Maybe you store it here and then you have to figure out a network to make sure it's also available on this computer and that computer. Maybe you install a program here and then you need this program to be available on this computer. Instead, you just have the program like Microsoft 365 available on the internet. You can use it on this computer, on that computer, and any other computer on your network. Okay, so those are different services that can get provided for you. Does that make sense?
Yeah, just.
All right, so that said, let's go back and talk about where we were. Where's my mouse? Of course, I can't see. Okay, so that is what cloud computing is. Whatever service you want. Do you want a particular application? They provide it for you. Do you want a Windows computer? They provide it for you. Do you want a Linux computer? They provide it for you. Do you want just a server where you're going to have all your documents or your pictures or your movies? They'll provide it for you. Then you don't have to worry about, I'm running out of space. I have to go and buy more hardware. I have to get someone to connect it. I have to get someone to update it. If you're running out of space, you just click a button, they add you space. If you need less space, you click a button, you reduce the space, and so on and so forth. So just with the power of, just with a click. But then all this infrastructure is provided for you, just like Grace said, right? You should be able to have storage, you can have databases, you have the networking, the connection of all those different things. As you can see in this picture, the database is there, the cloud is there, they are all interconnected to one another. Okay. And virtual machines. Just so you know, virtual machines, does anybody know what a virtual machine is? So let me go again and demonstrate real quickly. A virtual machine, normally you have a computer that you have created. The computer has a CPU, it has a disk, and all whatnot, right? It has your hard drive and a disk, a storage disk. All of those things, you can only run one operating system on top. What is an operating system? An operating system is what connects your hardware. Okay, these are all internal hardwares. The other hardware we know about is the screen, the keyboard, the mouse, speakers, all those other stuff. But it connects all of this operating system with your software. Your software could be Microsoft Word, your browser, everything that is running on your computer is a software, the ones that we cannot touch, right? But because you might want to have multiple computers, instead of having just one solid computer, you can go ahead and create copies of other computers inside your computer. Okay, so you want to have this computer, let's say it's using Windows 7, but then you want to create a virtual computer. Okay, so it's virtual, it's not real. So you create some space in your computer that's going to have Linux, for instance. When you have that Linux computer in there, that Linux environment created, that becomes a virtual machine. This virtual machine is still inside your computer. You can create another section again that has a Mac operating system. That also is a virtual computer. So you can have one machine, physical machine that you can touch, but within that one machine, you create virtual machines inside. Does that make sense?
Yes.
So that's what a virtual machine is. So what these guys provide for you is that infrastructure with virtual machines, because they are not physical machines that you can definitely compare with what you have. Does that make sense?
Yes.
All right. How about you, Mr. Egbert? Does that help? Oh, you're still on mute, so we cannot hear you.
I'm good. I'm good. I'm listening.
Okay, so how does this work? How does it work that you have your computer, somebody else having the computer, and then
Yeah, I was trying
you're
to say
using it?
something. So
Yes,
basically, I
go
mean,
for it, Greg.
like a virtual machine is almost like a program inside a computer that works as a separate computer inside the main computer, right?
Exactly, exactly. That's just like a computer, but then your computer, let's say this was my computer, right? I decide to just get part of the hardware to use it for the virtual machine. So if your computer has 200 gigabytes, you decide that I'm going to save 50 gigabytes to run a virtual machine on it. Then the rest of the 150 gigabytes is now yours. Does that make sense?
Yeah, so like possible, let's say for the virtual computer, basically virtual computer, which basically mirrored the main computer to have a different operating system. Let's say the virtual computer is having Linux, and then maybe your main computer is having maybe like Windows. Is it possible to operate as such?
Yes, yes. There are many ways that you can operate it. And I would like to talk about that more in details when we get to the part where we talk about infrastructure as a service. But let me give you a simple example. You decide that you have a house, right? And in that house, you have 3 rooms, 4 rooms, and so on. You know, depending on the circumstances, you decide that you want to rent out one of the rooms in your house. That person that comes in to rent that room, they'll have to have their own toilet inside, right? They have their own kitchen and so on and so forth. So that's still within your compound. So your compound then has the one house, and then that house also has like a guest room or a guest house. The guest room has their toilet and so on. Does that make sense?
Yeah, makes sense.
Yeah. So again, you can use your entire house. That's fine. But if you realize that you're wasting all these other spaces, let me just go ahead and rent this out. So that's what's actually happening in this case, where you have a room, or should I say not a room, where you have resources that are being allocated. You get a separate rate. You cannot go into that person's room because that is their room, that is their space that you're giving them. They can go into your room, but they can go into your living room, but they can't go into your room. So they have their own dedicated area. You have your own dedicated area per se. Does that make sense? Okay, so we'll talk more about it in future, but I wanted us to talk about shared responsibility model. So what is shared responsibility model? So what I want you to pay attention here is the right part. The very right here, it's showing on-prem. On-prem actually means on premises, okay? So when something is on premises, it's just like the traditional way that we used to do things. For instance, as you can see, the different responsibilities, back in the days, you have to have your own physical data center. Wherever you're working, maybe they have a closet where they have the servers that are connected to the whole network, or they have a particular room, which is a server room, or they have a particular building, which is a server building. But all of those make up a data center. And then you have your network, and then the host. The hosts are all the computers that are connected to one another. They also have your operating system. It is your job to install your operating system and update it and make patches and so on. It's also your job to make sure the network is being controlled. You have firewalls and all whatnot to take care of your network access. You also want to be able to be the one to create your own applications that are going to be used at work, and so on and so forth. Everything, you have control over everything with on-premises. But with shared responsibility model, when you decide to go on the cloud, you start breaking out of having full control. Depending on if you're using infrastructure as a service. Infrastructure, again, think about the building, the parts that make up your house. Platform, again, platform is built on the infrastructure. So after you've gone ahead and dig the foundation or dug the foundation per se, you get to now demarcate and say, okay, this is the room, this is that, and so on. I'm going to decide after the foundation has been laid if I'm going to build a mud house or a plank house or a brick house and so on. That's going to be your platform. After that's done, then you have your software, whatever is going to be in there. So with cloud computing, at every point in time, regardless of what you're doing, whether you're doing software as a service, platform as a service, or infrastructure as a service, you are the one responsible for your information and the data. You're the one responsible for the devices that have access to it, for the access that's going in, and you're the one responsible for the identity. For instance, if you're using Netflix, Netflix is software as a service. You're the one responsible if my phone is going to connect, or if you're giving your access to somebody else, or if you're creating an account for the kids or an account for someone else, and so on. So all of that is your responsibility, you the customer. But you also want to remember the cloud provider. In this case, we are talking of Azure, so we're going to talk about Microsoft. Microsoft is the one responsible for that physical data center, the network, and the host. As you can see, all these colors showing up here. So Microsoft will always be responsible for those. But depending on the service model, if it's SaaS, PaaS, or IaaS, which is infrastructure as a service, platform as a service, or software as a service, then you might be the one in charge of operating systems, or they might be the control networks, the applications, and identity infrastructure. Just a word here. Whenever I talk of applications, I'm talking about software. Okay, applications, software, programs, all the things that run on your computer, all the things that run on your operating system. Okay, does that make sense? Everybody okay with this so far?
Oh, yes.
Questions? So this is a very, very important slide. It's probably one of the most important slides today, but you're going to see it again and again and again. So now that we've talked about this shared responsibility model, let me jump in and explain each one of these models, what they do, okay? So for instance, let's start with, where's my mouse? Oh, there it is. Let's start with infrastructure as a service, okay? Why do we need to use infrastructure as a service? As you can see at the bottom here, oops, why did I click on that? I should not have clicked. As you can see at the bottom, you are essentially renting the hardware in the cloud data center. So you're just renting the hardware. You don't get to buy hardware. You don't get to do any of that. You just rent their hardware and then you decide whatever you want to do with it, whatever program you want to add, whatever operating system, you decide what operating system you want. If you decide that you want to use Windows, fine, you set up Windows. If you want to use Linux, you set up Linux. Only the hardware is provided by the cloud provider. So looking at the top left, you see that with this model, you have the most flexibility and you have the maximum control. Okay, the cloud provider is only responsible for maintaining that hardware. They'll make sure the hardware is new. They'll make sure that it's up to date and so on. They make sure that the internet is always connected to your hardware. That's their own job. And they make sure that it's secure. Otherwise, if you don't want that, then you're using on-premises. With on-premises, if you go and decide that you're renting a place in Douala to set up your servers, that's fine. You go to sleep at night and wake up, they have stolen it, that's your problem. Your whole system is down, you have to start dealing with it again. But now with cloud providers, that headache is not yours. Your server is never going to be down because they are in charge of security. They are in charge of maintenance. They are in charge of internet. If you decide that you want to go and live in Yaoundé at maybe near the, what do you call it, Hôpital Central, because the light never gets disconnected, the day that there will be no light, your system and all your servers will be down. But you're not going to have that problem when you're using cloud providers. We'll talk about those again in future. Does that make sense? Everybody good with that, I assume? So again, that is for infrastructure as a service.
Hello?
They provide you the hardware. Everything else is you. Next
Hello?
up.
Do you hear me? Wait, do you
Yes,
hear me?
yes, go for it.
Yeah, go. Yeah. So I just wanted to be so clear. So with infrastructure as a service, based on this schema that you just have here, so the first three, I call it sky blue,
Yeah,
from the bottom, are
yes,
provided by the provider. They are not under your control.
yes.
So the
go
ones
for
that
it.
are under your control are the ones that are the navy blue, the ones at the top after the first three, which are the responsibility that are transferred by the cloud provider, and then the other ones are the ones that you are bringing in, right?
Exactly. So
Yeah, good.
as you see at the bottom here, Microsoft, which is the one we are focusing on, Microsoft is a cloud provider.
Okay.
They are the ones in charge of everything at the bottom, except in on-premises, which is the traditional way that you do it. Okay. Otherwise, if you see navy blue or deep blue, then customer is you. You are in charge of that it's your responsibility, as we've talked about in the shared responsibility matrix. But in some cases, there's shared responsibility. You guys can split the responsibility. Does that make sense?
Yeah, it makes sense. But is there any circumstance where people still go with the on premises, like people are able to carry on the entire on premises application by themselves, that's providing everything?
Yes, yes. There are many, many cases people do that, but it's also depending on what you're trying to do. Tomorrow, we are going to talk about the benefits of cloud computing. So we'll look at the reasons why you don't want to be on premises, you want to be on the cloud. For some reasons, let's say for instance, if it's a medical institution, they are not sure about the security of the cloud providers. They want all their information to be located only in the hospital. Then they are going to probably want to do on premises. If it's sensitive information and they are not sure that, if they are being regulated and they cannot prove that the regulations are being met, then they'll probably do on premises. But for any other thing, I don't think it should be a major thing. Depending on your budget too. If it's a military probably has enough money to be able to build all their stuff in-house. But we're also going to talk about public, private, and hybrid clouds, which you should be able to make sense of that to see if it's better for you to have a private cloud versus on-premises. Does that answer your question?
Yeah.
Awesome. Very good observation. So infrastructure as a service, again, let's think about a house. If you decide you want to build your house and all you want the guys to provide the cement, the sand, the planks, the zinc. They'll just give you all that infrastructure, all this hardware, and come and drop it with you. And then it's up to you now to take it and start building from there. You start setting up your operating system and then building the network controls, adding the applications that need to be added, and so on and so forth before you can give people access. So that's what infrastructure as a service is. That structure is there. The hardware is provided for you. Everything else is on you. All right. So next up, platform as a service. Platform, again, think of, you have taken all those planks and then you have built your platform now. The platform as a service is the middle ground. There you get to split the responsibilities. Okay. Your own responsibility would be, or rather should I say, the cloud provider's responsibility, just like we said before, is having all those physical things that they had earlier, but now they are also providing you an operating system. They give you operating system and then they give you development tools. Development tools could be things like databases and development environment. So at the end of the day, it's very useful when you want to complete a development environment without having that headache of making sure you're maintaining it, it's updated, all the patches are there. They take care of the operating system. If there's an operating system update, they do it for you. You don't have to worry about doing that. You don't have to pay somebody to do it. Okay. If you want to create a new operating system, you just click a button, they create a new one for you. You don't have to pay somebody to do all of that. Does that make sense? Yeah. All right. Sounds good. Everybody is still on mute. So again, the only difference now is depending on your responsibilities. Do you want to set up the network configuration or do you want them to do it? Do you want to be in charge of the applications or do you want them to do it? That's why you see there is shared responsibility with all of these identity and directory infrastructure. Okay. And finally, let's talk about software as a service. Software as a service, if you look at a product or you look at it from a product perspective, then it is the most complete because you're only responsible for the data. You're only responsible for the access. You're only responsible for the identity and the accounts as is shown at the top here. Everything else is the cloud provider's responsibility. So it gives the most responsibility to your cloud provider and you have the least responsibility. Okay. So that is the final cloud model that we can discuss. But it's good that we have an idea when we can use either of these. What scenarios? So starting with software as a service, which is at the top, you can use it for emails like Gmail. You don't save your Gmail. Your Gmail is saved somewhere else. You're just using the internet to get access to your Gmail. That's why you can check your email on your phone, on anybody's phone, on your computer, on your laptop. It's still the same email you're looking at. For customer relationship management, if it's a hotel, they want to check out their customers, all that stuff, you need only the software. For collaboration, is it for email or for Google Suite, as you can see at the very top here? Microsoft Office, collaboration, Outlook, Word, PowerPoint, all of those are software as a service. It's provided on the internet. Salesforce is also one of them. Google Suite, all the Google platform stuff that we use, it's based on software as a service. So what is a model? Software as a service, you're just consuming it. So you're consuming the cloud. But platform as a service, you are building on the cloud. Okay? They provide you a web or a streaming platform, just like Netflix, or a web platform to build your website, or an application development platform to build your application. Decision support as well, if you want to look at decision making, business analysis, and so on. Those are all things that you use for platform as a service so that you can build on top of it. But with infrastructure as a service, that's when you're thinking of migration. Okay, so you want to move your things from on-premises and migrate it to the cloud based on the benefits that we'll talk about tomorrow. So that's when you see all of those.
But,
At the end of the day, the scenarios you want to think about for infrastructure as a service, which we just talked about, if you want to lift and shift, for instance, you have everything working in on-premises, but you decide you want to go to the cloud. So you go to the cloud, you build everything that needs to be built on there, or you request what needs to be requested. You lift your on-premises stuff and shift it to the cloud. That's how you just migrate it. Now everything is on the cloud, and then you can shut down your on-premise, or you can keep it for backup. Okay.
yeah, Vitus, let me ask this question I want to ask, like between the two blocks, let's say the platform as a service
Mhm.
and software as a service. I know one of them is like the consumer, which is the software as a service.
Yes.
Okay, let's say make accessing my email or so, right?
Yes.
Okay. What is the case like? I have my laptop, so I basically bought that hardware, right?
Yes.
The laptop or my CPU at home, and then I'm accessing the internet versus me going to a cyber cafe, which I'll just go and then maybe pay some money just to access the internet. You know what I mean? And
Yes.
that's maybe check my email at that cyber cafe. What do you differentiate between that, which I bought the laptop, let's say I have my laptop or my CPU, and then I still access my internet at the convenience, comfort of my home, versus went to the public place to just access my internet, my email there.
Okay, very, very good question. So at the end of the day, there are two kinds of computers, right? You have the client and the server. Okay. The concept here is that the server is there just to store all the information. All of that server, you can decide to have your own server. You buy a big computer that has more memory, more space, and more compute power to be able to save it in your closet or your basement or in a particular part in your office. That will be your server. But that server has to always be connected to the internet at all times. You don't have to lose power. You don't have to have any downside moments. That's a server. When you're connecting to your email, you're connecting to either Google server if it's Gmail, or Microsoft server if it's Outlook, or you're connecting to Yahoo server if it's Yahoo. They have a server, they have a dedicated computer that's just for everybody's email in this world. Okay. So that's that part. Now the client is you that is requesting a particular thing. The client could be your laptop, the client could be your cell phone, the client could even be an application, another software that's requesting that information. The client could also be that computer at the cyber cafe. So at the end of the day, it's up to you based on your convenience, how you want to access that server. So that server that we're talking about is the infrastructure. The infrastructure in this case is not the client. There are many, many clients out there. The client is your cell phone, your laptop, and so on. All of us are trying to access that data or that storage or whatever is being saved for us on the server. If you go to a website, The website has pictures, videos, all of those are stored on the server. So go ahead.
So you mean the hardware is the hardware being part of the infrastructure, or it can also be classified as being part of the software as a service?
Or the hardware is definitely the infrastructure. So
And if the hardware is the infrastructure, how do I consider my CPU at home? Is it the hardware or is not the hardware?
okay, so let me go ahead and paint this picture again, right? So you have, let me clean this up. You have this computer, which does not usually have a screen. That's called a server, okay? It's a big computer that is saving all your pictures, your emails, all that stuff, okay? That server is located somewhere which we do not have access to it. In addition to that, you also have your own computer, if I can draw correctly. That's your laptop with a keyboard. This is always requesting information from the server. The server is always giving it back. The hardware here is separate from the hardware there. Even your cell phone also is requesting all the information from
The server.
the server, and the server is giving it back the information that is requested. Now, this server, the server side is what we are talking about, infrastructure as a service. This is your personal infrastructure. This is the cloud. So your computer is not part of the cloud. It is your personal device, but the cloud again is for that company. Those big companies, be it your own personal company that you want to create. Do you want all this hardware to be saved in a basement or in a storage room? Or do you want it to be saved in a data center that's owned by Amazon, Google, or Microsoft? Does that make sense?
Okay, makes sense. So it basically means that, okay, we might have some CPU. Of course, those are still, even though we're kind of like, I'm trying to imagine it as being a hardware, but technically it's part of the client, that's the consumer's enhancement tool that helps them to access the server.
Exactly. So this is all the client stuff. The client has all this stuff. It has a computer, it has a cyber cafe, it has a cell phone, even your TV. Your TV is also using Netflix, or it's also using all those other apps. It's accessing it from the server, okay? But the server now is the one that's providing you the service. The client is just giving you access to that service, okay? Just like your browser is giving you access to the website. So when you look at it that way, then you can say, okay, I'm going to be using, do I need to get this infrastructure? This is all where the hardware is. And this is also where the hardware is, but this is the client side and that's the server side. The server provides services. So you come to a restaurant, all the food is being saved in the kitchen. They're going to take the food and chop it off, cook it, and provide it to you. Obviously, you're coming with your hands, your feet, your mouth to eat as well. But they also have hands that they use in the kitchen to make the food. But you also need your own hands to be able to eat the food. So that's how you have the server that has its own hardware that is in the cloud, and you also have your own hardware that makes up your client.
Makes sense. Okay.
Awesome. Very, very good question. So let's go back to where we were.
I have a question.
Yes, go for it, Mr. Egbe.
Yes. Anyway, it's just part of what you're talking about, but this is something I was reading a couple of weeks ago.
Yeah.
It's out of this. Anyway, I came across this word, X, that's X-ray, X as a service, XaaS.
Yeah.
As a service. So from what I was reading, it says that's anything as a service.
Yes.
I mean that's you don't provide nothing. The cloud provides everything for you.
Very, very good question. To explain the meaning of this question, it's actually a good time for you to ask it. So there are many things that can be provided for you on the cloud. Normally, like I pointed out, right? You have that big machine that has a bunch of storage and so on. That's a server. You can have multiple types of servers, okay? Based on what the server is giving you. You can have a server that's saving all your information to create a website. That will be called a web server. You can have a server that's going to just make sure that everything that you're having is being blocked or not. That would be a firewall server. You can also have one that's just for storing all your information. That will be a storage server. They are all different, many types of servers. Okay. And again, like I said, remember in IT, all these words are important. Server provides service. A web server provides web service, and so on and so forth. So all of these are services. XaaS means anything as a service. What do you want as a service? If we look at this on the right, do we want software as a service? Or do we want, in this case, is function as a service? Or do we want database or data as a service? Or do we want platform as a service? Or do we want storage as a service? Or do we want just the bare bones infrastructure or hardware as a service? Does that make sense?
Yes. And then there's another one that I read up. That was what actually threw me off. Container as a service. So actually, what does container really define?
Very good question. We will definitely get to container in a little bit, but just like I explained earlier, right? You have your computer. Your computer has hardware and software. You have decided that with this, your hardware, which has your CPU, like I pointed out earlier, your disk, and so on, you create a virtual machine. All of this hardware is being used by your operating system, right? To run what you have on your machine, but you can create virtual machines. Right. Instead of creating virtual machines, each virtual machine, let's say you create a virtual machine in here, this virtual machine will have its own operating system and will have one application, another application, another application, XYZ. And you can create another virtual machine, which is on operating system, right, that has application or software A, software B, software C. A container is separate because in this case, you have to create virtual machines separately. A container creates a container environment, and then you can just have multiple containers on top. Each container has just the services that it's provided. So now you're having that container as a service, which we'll talk about in a little bit, but let's not get into that right now. It's just going a step further from virtual machines. From virtual machines, you get to a container. So think about the container that you want to send to Cameroon. It can have everything in there. You just put whatever you want, bundle it up, and send it, instead of having only the particular things that you want. Does that help? Does that make any sense?
Just a little bit.
Yeah. But we'll talk about it clearly. You know, normally it was always one machine does one thing. Right. One machine, one operating system. Right. But now with virtual machines, you have a virtual machine and you create multiple virtual, or you have one machine and multiple virtual machines with operating system. But with the case of this, you have just one operating system and a bunch of containers on top, and you still have your hardware at the bottom. So let's not talk too much about that. I don't want us to get too confused with that, but that's what we're talking about in this case. Sounds good?
Okay.
Awesome, awesome. Very good question so far. I'm glad that everybody is building, because each time you ask a question, it's definitely helping others to understand one thing or another. But yeah, we'll talk about it more. But a few things I want you to remember today: lift and shift migration, testing and development, in that case, you want to use infrastructure as a service, because you can just request them to give you hardware. You go ahead and test your stuff, because you know that's the kind of hardware you have. You test your application, it works fine. Boom, now you can deploy it, everything is fine. With platform as a service, maybe you want to create a whole development framework and you want to use it for, I think this is wrong, I have to update that, for platform as service. But software as a service, again, using it for stuff like email and messaging, business productivity applications, like we pointed out here, CRM, finance and expense tracking, ERP, right? So platform as a service, you want to use it for streaming as a web server, decision support, application development, or development framework as pointed out. So we talked about this briefly. Infrastructure as a service, Amazon Web Service has EC2. Google has a Google Compute Engine. They just provide you with the, the hardware. Again, what is a computer? A computer is just dumb, but very fast. It's very fast because of the CPU. So what they are providing you is just the CPU and whatever other hardware, and they keep updating it. Storage as a service, it's not something that we need for this exam, but it's good to know some of those things that are being stored. Amazon has S3. You have iCloud for Apple. You also have Google Cloud Storage. You have Dropbox, Google Drive, OneDrive. All of those are storage as a service. The platform as a service, we have Microsoft Azure, Salesforce Platform, App Engine, AWS, and so on. And software as a service, we have all these different software that we use in Office or in Google Suite, Salesforce as well. All right. So at this point, I was supposed to take a quick break, but we have barely 30 minutes, 40 minutes left. So I'm going to take a 10-minute break. So it's 3:19 at my end. I'll take a 10-minute break. When we come back, we're going to continue with cloud models. Does that sound good?
Okay, good.
Yeah, so take a break, drink some water, do what you need to do. After the timer stops, we're going to... Okay, after the timer stops, we'll come back and continue from there. And when we come back, we're going to continue with the different types of clouds, okay? Whether it's private, public, hybrid, or multi. But for now, let's take 10 minutes. We'll come back at 3:30.